everyone. Well, in our last lesson, we learned how to find the mean or the average of a data set. Today, we are going to be looking at comparing means. And what does it mean to compare means? Well, let's take a look at some data that has been graphed. So this is a double bar graph. It's called a double bar graph because it has two bars that are side by side. Okay, you have city A and then you also have city B. And it shows the amount of rain that fell in a 6-month period. So in this double bar graph, we can see that we have city A and city B, and we can see how much rain in inches fell for city A in November through April, and then how much rainfall fell in city B from November to April. We can use this data and find the average rainfall for each city and look to see which city had the most rainfall based on what we see here. So we can use this data and compare it to two different cities. We could even do 3 cities if it gave us 3 cities, but this is just a double bar graph, not a triple. So let's first start out with city A. So let's write out this data for ourselves so that we have it all written out. So we're going to start with city A. City A, we can see that in November, in this dark green bar right there, we can see that it is 3.5. So we're going to say 3.5 is our first number. The next number was 2.2 inches. After 2.2 inches, they had rainfall of 1.9. In February, it was 2.1 inches. In March, it was 2.5 inches. And then in April, it was 3 4/10 of an inch. All right, so we've collected the data for city A. Okay, so we've collected the data for city A. Our job now is to do the same thing that we did yesterday. We're going to put these in order, add them, and then we're going to divide to find the average rainfall or the mean for city A. So let's start by putting these in order. 1.9. And then next would come 2.1. Next after that, we have 2.2. After 2.2, we have 2.5. Notice how it's 1, 2, 2, 2. And since all of these start with 2, we're just going to start looking at what comes next when we're ordering these. Okay, now we're up to the 3s. So 3 inches and 3.4 is less than 3.5. And 3.5 was the most. So we're going to add all of these numbers now, and then we will do some division. So let's go ahead and move our graph out of the way. There we go. And now let's check out adding. All right, so when we're adding decimals, it's really important that we put them into the calculator by making sure you hit that decimal point. Otherwise, you would get a whole number instead of a decimal. So be really careful as you're putting these numbers in. 2.2 plus 2.5 plus 3.4 plus 3.5. So a grand total of 15.6 inches. So in that 6-month period, they had 15.6 inches of rain. We want to find the average. This is not the average. It does not fall within that range. So 1, 2, 3, 4, 5, 6. So we're going to take 15.6. We're going to divide that by 6. And that is going to give us our average rainfall. Your average rainfall is 2.6 inches for City A. So that is the mean. Okay, now we need to still do City B. Okay, so they told us that we need to find the average, and the average is going to be looking at the comparison, right? So we're comparing. We want to compare them, look at the differences between the two. So now let's look at City B. So we're going to go ahead and look at City B. Maybe I should use a different color. So we're going to go ahead and do City B. And there we go. Now you can see it. City B is the light green that's right here. Okay, so we're going to look at the second bar and be really careful as we take those numbers. So the first one says 1.7. The second one says 1.6, 2.2, and 2.1. Then for March, it was 2 7/10. And for April, it was 1 7/10. Okay, so now our job is to put these in order, just like we did before, from least to greatest. So let's go ahead and do that from least to greatest. We've got a lot of ones here, so let's start with those. And we have two 1.7s, so we're going to put both of those down. Oops. 1.7. Sorry, that number looks a little weird. Okay, and then, oh, but I missed 1.6. 1.6 should come first, right? So 1.6 should be first because 6 is smaller than 7. So 1.6, 1.7, 1.7. Now we're at the 2s. So 2.2, 2.1, and 7. So 1 is smaller. So 2.1 followed by 2.2. And 2.7. Okay, now we are ready to add these and get a total. So we're going to add all these up. So let's add these up. 1.6 plus 1.7. Again, watch your decimals. 1.7 plus 2.1. Plus 2.2 plus 2.7 for a grand total of 12. Okay, so now our job is to take this 12 and we're going to divide it by 6. 6 data points. We know that 12 divided by 6 is 2, so this is 2 inches. Okay. Now, our job is to compare. We're going to compare these two. So, City A has more rain than City B in 6 months. So, over the 6 months, City A received 0.6 inches or 0.6 of an inch more rain than City B. So here is our comparison. You could have written a comparison that said that City B received less rain than City A. Whatever the question is asking, that's what you want to write your comparison with. Okay, so over the 6 months, City A receives 0.6 inches more than City B. All right, now sometimes you don't have two different datas, right? So this was City A, this was City B. And you're comparing those two cities because that's what we have. Sometimes your comparison has to come within an outlier. So here's example B. Let's go ahead and look at example B. And example B has an outlier. Okay, so we had some ponies, and those ponies have some height. Not really, because they're short. Shetland ponies are short. So these ponies are, let's do height in inches of ponies. So these pony heights, we had 40. We had 38. We had 37 and another 38. This pony was 39. This pony here was 37. We had a 40, and we had a 28, and we had a 42 and a 40. Okay, so our job right now is to put these in order from least to greatest, and then we're going to start looking at the word outlier. Okay, so we're going to put these in order from least to greatest, and then we will look at the outliers. So 28 is our smallest. So we're going to say 28, followed by, do we have a 30? No 30, but we do have a 37. Ooh, interesting. 38, 38, and then, oh, I missed another 37. Okay, we're going to squeeze that 37 in. I keep doing that. I need to check better. Okay, and then we have 39. We have 1, 2, 3 40s. 40, so 1, 2, 3, and then a 42. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I could have put this on a dot plot, and that dot plot would have been much easier to read. So we could have put these in a dot plot, but we didn't. If you want to still organize them in a dot plot, you can. Sometimes it will ask you to put it in a dot plot. We're just putting them in order from least to greatest right now. But we're going to look at these numbers and see how these are grouped, right? So when we were writing our numbers, we jumped from 28 all the way to 37 and then just went to 42. You can kind of see that this information here is grouped, right? So if we were to have this in a dot plot, which I'm going to show you what that dot plot would look like. So let me get that for you. Okay, so here's our dot plot. You can see that you have a cluster of data right here, right? And we have this 128 way out here with this big gap. We call this 28 right here an outlier. It's either much bigger or much less than the other data. So we're going to use this word outlier. An outlier, we can find the average of the data with the outlier and without the outlier. So we're going to go ahead and do that right now, and then we're going to compare. So let's start first by adding all these up together using the outlier. So we're going to do it with the outlier and without the outlier. So let's start by with outlier. So let's go ahead and add all those up and find our average. So our average starts with 28 and 37 plus 37 plus 38 plus 38 plus 39 plus 40. 1, 2, 3 40s and a 42. So that gives us a total of, with the outlier, 379, and we're going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide that by 10 data points. Oops, see, you gotta be really careful. 379 divided by 10 data points is 37.9 inches tall. Okay, now we're gonna do it without the outlier. Okay, so without. So without the outlier now, we're going to just take this 379 and let's just get rid of this 28. So really, we're going to add up all these totals again. 37 plus 37 plus 38 plus 38 plus 39 plus 40 plus 40 plus 40 plus 42. And that gives us 351. And we're going to divide that by 9 pieces of data instead of 10 because without the outlier, we only had 9 data points. So divide by 9, and that gives us a total of 39 inches tall. Okay, what do you notice about these two data points? What are you seeing here? Well, I'm seeing that a pony, with just looking at the cluster of data, that outlier is really affecting how tall the pony is because that pony was so short. So the outlier made the inches tall smaller. So the outlier says that our average causes the average data to be shorter. So the outlier, and we're going to talk about outlier again. Outlier is the smallest or largest data that doesn't fit, made the average shorter. Okay, all right, we're going to do a try it now, just one. So go ahead and finish writing this out. We've got the outlier, the smallest or the largest data that does not fit within the cluster. And we're going to look at doing one try it with a comparison. So we're going to compare the data. So let's get your try it. So your try it for today is you are going to be comparing the means. Let's find you an example. When we're looking at kittens. Okay, so we're going to look at the kittens and we're going to talk about the outlier in the kittens. Okay, so your try it. Try it number 1 and only number 1, we are looking the weight of kittens. So kitten weights. The weights that we have are 4.5 pounds, 5.7, 4.4, 4.45, 5.5, we have a 5.6 and a 4.7. We have 4.9, 7.25, ooh, that's a big one, and a 5. Okay, so first thing is that I want you to compare this using the outlier. So just like we did in our last example, you are going to use the outlier and then not use the outlier. When you're finished, come on back and hit play so you can check your level of understanding. But right now, go ahead and hit pause so you don't hear me solving kitten weights with an outlier. All right, so first I'm going to look at with outlier. So I'm going to look at it with the outlier. We're going to put these in order from least to greatest. So my outlier, I can tell already, is this big number, 7.25, because it doesn't fit within the 4s and the 5s. It jumps. So it's an outlier. It's out of bounds. So it's outside of that range of 4.4 to 5.6. It looks like 5.7. So let's start with the first one. 4.4 plus, we have a 4.45, and then what do we have? A 4.5, and a 4.7, 4.9, then what do we have? We have 5, and it looks like 5.5, 5.6, 5.7, and then my outlier, here's my outlier right there, 7.25. That's my outlier. So I'm going to do all these numbers with the outlier and then do all of them without. So let's go ahead and add these up and see what we get. 0.4 plus 4.45 plus 4.5 plus 4.7 plus 4.9 plus 5 plus 5.5 plus 5.6, 5.7, and 7.25. So here it is with the outlier. We get 52. And there are 1, 2, 3, 4, let's go up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide that by 10. Move our decimal point over 1. 5.2 pounds. 5.2 pounds with the outlier. So now we're going to look at without. Without the outlier. All right, so we're going to add all those up and divide by 9 because 9 data points this time. I'm also just going to take this 52 and I'm going to then subtract my outlier from it because that's an easier way to do this. And I get 44.75 and I'm going to divide that by 9. So divided by 9 and that gives, oh, that is a big number right there. All those 2's, we can ignore those because they don't change the 7. We would just round. So the number is 4.97 pounds. So with the outlier, the cats weigh more with the outlier. So this little kitty right here is making all the other averages go up. If we remove this kitten from the litter, we have less than 5 pounds is the average kitten. Okay, how are you feeling right now about finding and comparing means? How do you feel about that? Go ahead and answer your essential question. How do we compare the mean of, or the averages of data? So how are we comparing? And then put your level of understanding out to the side. Where are you at? 1, 2, 3. Need more practice. No clue what's going on. Ooh, I totally get this. We're still just finding averages. And then we just have to talk about the outlier or the one on the outside. Okay, now, if you are good and you totally understand this, you are welcome to go on and do your practice work. If you need extra support, please come on back to the Google Meet and ask for help. Otherwise, have an awesome day, and I will see you all next time. Make it a great day.